So it's going to be a little bit in this video. We'll try to go as quickly as we can, but make sure you pause and rewind and what you need to do to understand everything here. But we're going to take this whole right triangle thing and we're going to actually put it onto a coordinate system. Coordinate system, something obviously with an X and a Y. So for example, this is your Y-axis, and down here would be your X-axis. And we're going to look at angles and triangles that are formed by, so you see this arrow here. So we could take this arrow, and this would be 0 degrees. It's flat along the X-axis. And then that angle would increase, 5, 10, 45, about there, all the way up to 90, right, straight up. And then it would go past 90, 100, 110, and so forth and so on, until you got all the way in the other direction, which would be 180. And then 190, and so forth and so on. And in fact, here, let's put a couple of these in here real quick. So this might be one angle. So this represents a handful of angles. So this might be, and I'm just making up some numbers here, but maybe that's 40 degrees. Maybe this from here to here is, let's see, let's go 160. 20 degrees shy of 180. Maybe this one is, let's say 15 degrees past 180. So that'd be 195. Notice this angle is an important one to know, though. That's 15. The way I set this up, I made this 20. What about, I'll do this one in a different color to make it stand out. What about this one? All the way around to here. Well, the angle I'm interested in is this one. Well, I'm going to estimate that. Let's say that's about 25 degrees. So if that angle is 25, what is this angle? Well, remember, all the way around is 360 degrees. By the way, it's closely related to the number of days in a year, but it's 360 degrees. So we're short 25 of those degrees. So 360 minus 25 is 335. So this angle will be 335 degrees. So what I want to point out here is that while these angles are crazy, big numbers and so forth, and they don't apparently, you can't stuff them in a triangle. A triangle is supposed to have 180 degrees total. What are you going to do with 335? But it does, in fact, form a triangle. If we use that one as an example, you can create a triangle, a right triangle, using that and this. And you have a right triangle, right? Where this is the 90-degree angle. And while 335 is the angle from here all the way around, I really can use this angle right here and find stuff out using that. So this angle, and this angle, and this angle, and this one are all angles. Notice they are all angles made with the x-axis, not the y. So like, for example, this is not an angle that we would consider. I mean, it's not like it's not an angle, but it's not, we're going to always consider the angle to the x-axis. That angle has a special name. It is called the reference angle. Reference angle is always the smallest angle made with the x-axis. And by smallest angle, I mean this right here is 25, right? Well, I'm not worried about this angle here to this side of the x-axis. I want the smallest one. Let's get rid of all this gobbledygook here. And let's pick it up from here. In fact, yeah, let's pick it up from here. So we'll do a simplest case here in the first quadrant. Do you remember what that means, right? First quadrant. This is the second quadrant. This is the third quadrant. And down here is the fourth quadrant. Here in the first quadrant, your reference angle is the angle. So it's the simplest case. And there is a right triangle here. I'll try to use red, like I did before, for this, and blue for this. I'll try to make this a 90-degree angle. There we go. So here's a right triangle. This is obviously your hypotenuse. Sometimes when we use it in a coordinate system, it goes by the letter R. This is our angle and our reference angle. The reference angles would be a little R next to it like that, but in this case, it's the reference angle and the angle are the same. What is the red? Well, let's go with the X. What is the blue? Well, the X. Well, yeah, what does this blue dotted line represent? Well, that is the X coordinate for this spot right here. And the Y coordinate is this, that height. So the legs of our right triangle, no matter where it is, are going to be the X and the Y. And in this case, for example, they're both positive. But if you had one that looked like, let's go over here. What about this one? Well, your Y would be positive above the X-axis there, but your X would be negative. But it's still going to be the case that this leg is the X value, and this leg here is the Y. And this point here is the point X, comma, Y. This is our reference angle. The actual angle, we'll do in this purple color, is from here to here. That's theta. But this in black there is our reference angle. And really for us, since we know right triangles pretty well, that's the one we want. So you can figure this out though. If they told you that the angle was, let's say that angle is 145 degrees. What would your reference angle be? What would this be? Well, you know that all the way over is 180. So if you take 180 minus the 145, you get, make sure I get that right, 180 minus 145. That's a 35-degree angle. So our reference angle is 35 degrees. And then if I knew the Y or the hypotenuse, like I said, they'll call it R a lot, or the X, if I knew one of those three things, I could find everything else I need. But I would keep in mind that when I was done solving this right triangle, that this should be negative, because it is over there on the left-hand side. And in fact, it might not be bad to note that, and we'll do it in green, that in the first quadrant, X is positive, Y is positive. Over here in the second, X is negative, Y is still positive. Down here in the third, X is negative and Y is negative. And in the fourth, X is positive and Y is negative. But we can solve any of these based on that information. So let's do an example here. So let's say I have, let's make one up real quick. So I got a Y-axis, I got an X-axis. I'll put, let's see, we'll do one down in here. All right, and let's give some information. Let's say that the actual angle, theta, from there to there, is 197 degrees. And let's say r, the hypotenuse here, which, like I said, they'll oftentimes call it r. Let's say that is 9.2 meters. There we go. So what I want you to find are the following. You could probably already guess. I want you to find the y side, the y component, or coordinate, the x, so I want you to find y, I want you to find x, and I want you to find, you're going to need this, I want you to find the reference angle. I'm going to have to use a different color here, or change this a little bit. All right, there we go. I want you to find the reference angle. Let's start with that reference angle. So if I know it's 197 from here to there, well, I know it's 180 from here to here, so I'm going to take 197 minus 180. And that's going to give me a 17-degree reference angle. So this is 17 degrees. All right, let's go after the y first. Well, for the reference angle, the y, and this is always true, when you're using a reference angle, the y is always the opposite. So you think, so what trig function are we going to use? Well, if we have the hypotenuse and we're looking for the opposite, that's going to be sine. So the sine of our reference angle is going to equal the opposite, y, over the hypotenuse. So you can use r or h, really doesn't matter. But what I want to point out is that most of the time, when we're working in physics, I want you to start associating sine with y. Say sine, think y. So in this case, that would be the sine of 17 degrees equals y over 9.2. And I solve that by multiplying both sides by 9.2. And I get, let's see, sine of 17 times 9.2, and I get 2.69 meters. And now I'm going to find x. So for x, what trig function are you going to use? Well, if you're using the reference angle, that's the adjacent, and you're going to want to use the hypotenuse here. So that's cosine. And I want you to start associating cosine with x, because for many, many, many times that is going to be the case. There will be a couple of exceptions, but we'll get to those when we get to those. So cosine of the reference angle is x over r, so we're going to have cosine of 17 degrees equals x, which I don't know, over 9.2. Multiply both sides by 9.2, so I'm going to take cosine of 17 times 9.2. All right, x equals cosine of 17 times 9.2. Multiply both sides by the 9.2. I'm not going to write that out every time. And x is going to be equal to 8.80. So now I know that. Now, the only thing that's left is this. I got to be careful. In the coordinate system that we see, x and y in this third quadrant should both be negative. And I can always do that at the end. I wouldn't even bother using the negatives there. Now, the hypotenuse will always be positive. And so there we have an example of how to solve one of those. Of course, if you're missing the angle, if you're given a couple of the sides, then you're going to use inverse sine or inverse cosine or inverse tangent, one of them, to find the reference angle and then go back and calculate the overall angle from there. Give these a shot, and once you're done those satisfactorily, you will be done the trig part of the assignment. Well done.